Greetings and welcome, friends. Page 32 and 33 now, guys. I'm so old. I remember when I was 32 like it was last year. But we're taking a look at solving absolute value equations using our kind of previous skills and one additional trick in which I break it up into two. Let's just jump right in. Let's go. It says solve the equation, graph the solution or solutions if possible. All right, so the big idea with absolute value was first get the absolute value by itself on one side of the equation, and then you break it up into two separate equations. So I'm going to have either W is 6 or W is -6. Now, the reason this makes sense is because absolute value will take a positive number and leave it. So the inside of this could have been +6, and then the absolute value made it 6, right? So that makes sense. That's case number one. Case number two is that the inside of this absolute value was negative, right? So maybe W is equal to -6, and then the absolute value made it the +6. So these are the two possible cases for this absolute value equation. I break it up into both of those cases and then solve. But in this case, these are already solved. So I'm going to actually write or between them because it's not both of those things simultaneously. It's one or the other. And those are our solutions. And I can graph them on a number line. My graphs, I'm not looking for anything fancy, just like this, right? So you don't need to fill in all the tick marks. And then when I graph, let's see, W equals 6 is right here. W equals -6 is right there, okay? So let's see, let's look at this next one, a little more interesting. So here we go, I've got absolute value of n plus 3 equals 7, break it up. So I break it into two cases. You can only break it up, by the way, once the absolute value is the only thing on its side of the equal sign. So I will have maybe n plus 3 was +7 and the absolute value was useless. Maybe n plus 3 was -7 and the absolute value made it positive. So those are my two cases, okay? And now I solve using my normal algebra, right? So here, m plus 3 to solve for m, inverse operation, subtract 3 from both sides. Hey, it's the same step over here. I've already got this color selected, might as well keep using it. So I'm going to get m equals 4, and over here I'll have m equals, that's becoming more negative, add them up, keep the sign, throw an or between those, and bam. Right? Nombre line. This one's a little bit more interesting. Let's see, from negative, I have to go as far as -10. Let's say 0 is here, and 4 is going to be closer than 10 was to 0. So at least kind of have your scale match a little bit if you can. So I'll have -10 was a solution, and 4 was a solution. Now, I want to point out something here. I forget what color I consistently use. But this +3, if I actually look here at -3, that's the center between those 2 points. And the 7, use a lighter blue, up in the black, is actually the distance, all right, from the center to those points, 7 units away, 7 units away. Okay, so notice that the center between my solution set is the opposite of the number within the absolute value, okay? I've got to keep reminding myself of this so that way I can do it when they ask us to do that straight up. Let's see, here's some more questions. Let's cruise right through these. So this one, break it up. I would end up getting 4b minus 5 is equal to +19, or 4b minus 5 is equal to -19. Right? So I break it into two cases. Do not, and I've seen this so many times, it makes me cry on the inside. Sometimes people will just be like, oh, let me just +5 to both sides. Oh, guys, super illegal. Super illegal. This 5 is like stuck inside the absolute value. I can't access it until I've dealt with the absolute value. So super illegal. Don't just try to like solve it and pretend as though absolute value is not there. You will any of those points. Got to do the break it up part. All right. And then let's see. Then I would solve normal style from here. +5, +5. Oh, see. So I'm solving both of these simultaneously. So remember when we add 5, we do it to both sides of the equal sign. I did it over there. did it over here, I'll get orb is equal to 24, and over here I'd have forb is equal to 19 and 5. They have different signs. I'll subtract them. I'll get 14 and keep the sign of the more influential. Let's see, what's the inverse operation of multiplying by 4? Friends, divide both sides by 4. Not 4b, just 4, because I want the b to still be there. If I divided by b, it would accidentally cancel it out. I wouldn't want that to happen, right? I want b to be there. So let's see, I'll get b is equal to 6. Man, sometimes my b's look like 6s, friends. Over here, oh, I should have saved my color and just done both simultaneously. Divide by 4, divide by 4. Now this is a fraction that I can reduce. What's a number that goes into both 14 and 4? Well, they're both even, so 2. 2 goes into 14 7 times, and 2 goes into 4 twice. 3 wouldn't. In terms of division, is what I'm asking what it go into. Right? What's a number that divides into them evenly? Kind of what I'm asking. So here b is equal to -7 halves. All right, which as a decimal, in this case, I can get an exact solution is -3.5. So if I was to plot that on a number line, that's what I would do. Throw an or between those, right? And that's what I would get. I'm not going to take the time to graph that one because I want to make sure I get to these more interesting problems. All right, this one, I can't break it up yet, friends. Oh, man. Why can't I break it up? Does anyone know why? Yeah. There's other stuff with the absolute value is the issue. I've got to get the absolute value by itself. You could almost pretend, imagination, that the absolute value is like a variable, and just pretend this said -2x plus 3. Okay, and now I've got to get rid of the -2 and the 3. So I would use inverse operations. So here, I'd deal with the 3 first, so I'd subtract 3 from both sides. This one reduces in complexity. That's okay, though. Equals -2 abs val of 1/4 s minus 5. And I want to point out, you cannot distribute multiplication into an absolute value. All right, it's a no-go. In some situations it might work out, but just don't even start the habit. So the -2 is being multiplied by that. I divide both sides by -2 to cancel that out. What's 0 divided by anything? 0. Right? Let's see, and I'd have 1/4. Oh, abs val. That's right. S minus 5. So now that I've isolated the absolute value, now I could do the break it up step. In this case, the break it up step's not that interesting. I'm either going to have 1/4 s minus 5 is equal to 0, or 1/4 s minus 5 is equal to -0. But that's just kind of not helpful. It's the same thing as over here. So you would really only have to solve one of these. There's only going to be one solution here. And that's what we'd end up having. But I just want to point out this concept of right here, all of this work is isolate the absolute value. Okay? Isolate the absolute value. Get it by itself is what we're doing here. All right? All right. Another thing that you have to be concerned about absolute value, I don't think any of these problems have had issue yet, is that you would have to check for extraneous solutions. Sometimes, even though you did everything right, the solution still doesn't work. So you do have to check for that. Let's see if I can figure out some of these. Okay. All right. So we mentioned that the number inside the abs val is the opposite of the midpoint of the graph. Okay, so I'm actually going to write that down so I remember. If I write something down, I'm like 20% more likely to remember it. Did you know that? Psychology, man. That's what they've determined. The opposite of the midpoint. Okay? And then the number that the absolute value is equal to, okay, these guys, is the distance from the midpoint MP to solutions, right? The points that we plot that are the solution set. Okay, so let's look at 27. The midpoint is going to be the opposite of 2, so that's going to be at -2. Oh, it looks like I've already isolated my case. There's only one that had a -2 midpoint. And it's going to be, the solutions are going to be 4 units away. So B is going to be the answer. Get a nice forest green here. B would be the answer to 27. All right, 28. The opposite of -4 will be my midpoint. So that's +4. The distance of my solutions from that midpoint is 2. So there's +4, go this way 2, go that way 2, plot my points. D is the solution right there. All right, I'm telling you, I've got to practice this myself. This wasn't something that I've previously memorized. Right? I mean, I could solve those equations and then graph, but to just generate the graph right off the bat, whew, or to do that in reverse, like when they give you the graph and then you have to write the absolute value equation, man, I'm right with you, friends. Let's see. So here, the midpoint would be the opposite of -2, so that's +2, and the distance is 4. So +2, go this way 4, go that way 4. There's my solutions. In this case, C is the graph of that equation. And then lastly, -4, 2 units away both sides. A would be the solution. Let's see, just as a challenge, let's see if we can do this in reverse. What if I wanted to write the equation? What if I have this? 5. Let's say I have my solutions at the points 1 and 5. Right, so here's 1 and 5. What is the midpoint between these two? All right, I got a 3, yeah. And what is the distance from the midpoint to either of those solutions? 2, okay? So if I wanted to write the equation, the absolute value equation of this, I would have the absolute value of x or some variable, all right? This midpoint was at 3, so do I write +3 here? No, I got to write the opposite of that, right? So I'm going to write -3. And then let's see, and then it's got to equal what? The distance from the midpoint to the solution, 2. Okay, and if I was to break this up and solve it, that is in fact what I would. All right, well, thank you for watching, internet friends. Hopefully you are having an absolutely wonderful and valuable day.